Welcome to the Austin Forum Upload, the podcast of the Austin Forum on Technology and Society.
Every episode, we upload for you the expertise, insights, and opinions of thought leaders, innovators, and creators on topics at the intersection of technology and society.
We'll cover pervasive and emerging technologies that are influencing and impacting our business, education, governments, research, and culture.
I'm Jay.
I'm Jessica.
And I'm John.
And we're the co-producers of the Austin Forum Upload.
Hi, welcome to the Austin Forum Upload. Today we have another episode of Artificial Intelligence Facts, Fiction, and Fun. I'm John Lockman.
And I'm Luke Wilson.
And I'm Jay Boisseau, and we are very pleased to have our friend Matt Sanchez, the CTO and founder of Cognitive Scale, with us today to get his take and his AI facts, fiction, and fun entries. So welcome, Matt.
Thanks, Jay. I'm glad to be here and looking forward to the discussion.
We're glad to have you. We're going to make this a regular series throughout the year for the Austin Forum Upload. And we're very fortunate that we know so many people in this space, since our day jobs all involve artificial intelligence work as well. So let's get right to it, Matt. Our format is AI facts, such as news, achievements, popular results, etc. in AI, then fiction, some use of AI in fiction or to create fiction that you noted. And finally, just something fun that you noted recently in AI. And we're going to start with facts. You want to share with us something recent in AI that's made a big impression on you?
Yeah, there's something that caught my attention lately because I've always been interested in the notion of AI that is adaptive, that learns in the sense that as situations change, it learns to adapt to those changes and improve. And most AI doesn't do this today. So AI we typically equate with deep learning, machine learning, and most of these systems learn from the data you feed it, and then they create a model, and that model does what it does. And if something changes, the model doesn't change on its own. You have to go retrain it or update it. That's how most of these systems work. But there's been a lot of research in this area, and in particular with the interest in things like autonomous vehicles, to have machine learning systems that can learn on the fly. So as new situations arise, maybe what they learned about those situations in the past, they need to forget and learn the new rules, so to speak, in order to be successful. And so there was an article recently by MIT that talks about this concept of liquid machine learning systems. And by that, they mean systems that whose the parameters of these neural networks can actually be change on the fly. These networks can learn how to vary essentially these parameters depending on what's happening, in real time. And an example of where this could be applied, something that we've actually at Cognitive Scale been looking at for a while, is sometimes maybe you don't have enough information when you build one of these models, but maybe there are multiple different scenarios that you might want to include in your system, and you want the system to figure out which of the models is the best one to use. A simple example, not so simple, but an easy to understand example, is if we're sending a spaceship to Mars, and the situation as that ship is on its way through space changes such that we have to make changes to to the course that it's on. We might have models that know how to do that, but depending on the situation, there's probably different models we want to apply. So if we wanted to send a completely autonomous spaceship that's disconnected from Earth, how would it figure out which of those models to use to make adjustments in an emergency situation? Or if an asteroid was hurling towards it and now it needs to go around it, it may need to adapt to these situations that we couldn't really fully program into it before it left Earth. And so this idea of being able to dynamically change how these systems work is a really interesting aspect of research. And so MIT has been working on this, and so they've introduced this concept of liquid machine learning, which really is about how to vary these parameters. I think it's a very interesting area. I think it's also related to advancements in reinforcement learning, which is a style of machine learning that's used in robotics, it's used in autonomous vehicles, and it's used in business. Probably the most well-known example of reinforcement learning in business is with trading stocks, and where you're training reinforcement learning to figure out how best to adapt to changing market conditions and make profitable trades. But we can use it in other ways as well. We can use it in business to figure out how best to achieve a particular goal. What are the sequence of steps we need to take in order to get to that goal? And they may be different depending on the situation. And so we need the machine learning system to figure out how best to sequence things, and perhaps change its mind about that sequence if the situation changes on the fly, which is often the case in business when we're dealing with human beings, where human beings change and their behavior is not fully predictable. And so we need to adapt to that. So this whole idea of adaptation, I think it's a little bit unfortunate that machine learning has the learning in it and the way it's classically applied, because it really doesn't learn the way humans do. Humans are very good at adapting. Humans are very good about seeing something, even if you've been trained to do something a certain way. If something doesn't look right or feel right, you have these instincts that kick in and you change your approach to try to adapt. And that's a very, very hard thing to do in an algorithm that we put into a machine. And so this area, I think, is where we start to get closer to machines that can sort of adapt like humans adapt, which is, I think, a huge area of advancement in the field. And so I'm always looking for signs of work going on in that area. And this one caught my attention last week.
Yeah, I think the adaptivity space is really interesting. I always have concerns, though, when you're talking about training models kind of in the field. It always brings me back to the problem of, not just generalization drift, but having completely new environments skew the purpose of the model. And I don't know if this work from MIT is similar, but I remember, and I always bring this example up, the idea of Microsoft Tay. It was a great language model until they dropped it on the internet. And what do you do when you drop a model in an environment like Twitter or Reddit, something like that, and all of a sudden the universe that it lives in is not conducive to the type of output you want to have?
Well, if you look at anything like the output from GPT-3, it's, wildly racist, sexist, because all of that text has been pulled from Reddit comments and Twitter and the internet, and it's actually a system that we built ourselves, and it's feeding it back. So when you build a system like this that's going to continuously learn, how do you know what to point it at? I think is the point there, right? How do you get it to look at the right things so that it's going to train itself to actually solve the problem that you wanted it to?
Yeah, those are good points. I think, I like to think of the example of if I were to train a car how to drive in Austin, Texas. People in Texas are generally pretty friendly. Well, especially when you compare them to how people drive in my birth state of Massachusetts, where it's pretty cutthroat up there. So what would a car do if I trained it to drive with our friendly Texas drivers and then I dropped it in Boston? Would it learn some of the bad behaviors that exist there? It's interesting to when you think about adaptation, it might have to, or it's going to not get very far. I also think that you have to also, when you build these systems, think about these issues. How do you put the right guardrails around them? Because, I think if you were to take, this is sort of the nature versus nurture conversation and with human development as well, right? If you were to take a human being from birth and put them in a really violent, harsh environment, would they grow up to, inherit some of those behaviors? And, I think there's research that show that they probably would. And I think the same is true for these systems. They're learning based on the information they're being fed. And if you feed it garbage in, garbage out, you feed bad information in, some of that's going to come out. And so how do you guard against that? And I think, we see this even in social media platforms. The same algorithm that helps a brand sell their products to millions of people is an algorithm that can spread hatred, can spread violence. It's this megaphone that you put things in, and what comes out is not always what we expect. So the Microsoft Tay example is a good example of, not understanding how a system is going to react in a certain environment. But we also have algorithms which, if they don't have the right guardrails around them, you put the wrong things in, and it's going to be a force multiplier, but not in the way we want it to be. And so we do have to think about the boundaries of these systems. How far, is there a kill switch? Is there a way to kind of prevent them? Can we are they self-governing? I mean, if they may be self-learning, but are they also self-governing, or do we need to put systems in place to manage them too?
Well, you bring up some really good points about the need for understanding ethics in AI. And I realize that's a very popular buzzword lately, is ethical AI. But as difficult a problem as that seems, as you said at the beginning, many of our machine learning models are kind of finite in what they can learn. So if you can do a good job of making sure that you have unbiased data, you've removed all bias from your data, you can test it on a number of use cases within a parameter space, you can have some degree of confidence that you haven't created an unethical AI. It just may be a very limited AI. But you're in this example where you talked about reinforcement learning and liquid approach to it, it seems like you have to have those guardrails in, because you can no longer count on your parameter space being finite. So it can learn things outside of that. And it seems like guardrails are going to be especially important to ensuring the ethical use of AI as we develop models that can learn beyond the narrow scope that we code them in their original form.
Yeah, and I think there's so much diversity in these different styles of models. So when somebody comes up with a new approach like liquid machine learning, we need an ability to measure things like bias in those models. We need the ability to explain how they're making decisions, independent of how those models are built, because of the diversity in these different types of algorithms. And so, an area that I've been working on for a long time is this idea of treat all the models like black boxes, meaning I don't need to know. I shouldn't have to know. If it's a deep learning model or a bunch of rules, I don't care. I should have a standard way to evaluate things like bias, fairness, things like robustness. Is the model going to start making wrong decisions with just small changes to the data, or is it more resilient? That becomes interesting from a security perspective as well. If you have models involved in making decisions about cybersecurity, for example, how secure are those models? Can they be spoofed easily? So I think we need techniques to be able to do robust measurement and evaluation. And we do need, I think, if you look at the ethics side of it, we need as a society to define what the standards are. What do we consider to be fair in these different situations? What do we consider to be trustworthy? Like if we're going to automate something, we better be able to trust it. And so we need to define what those boundaries are and have ways to actually measure them.
I think you were really onto something with your car example, Matt. Training something in Texas, then dropping it in Massachusetts. And so I'm just going to say this before we move on to the next section. Elon Musk, I know you're listening. When you build the next generation Tesla to have full self-driving capability, you need to put speakers on the outside of the car so that it can yell at other drivers on the road. It's going to have to fit in its environment. So
it's going to have to learn how to drive on the shoulder at 100 miles an hour if it's in Massachusetts. So that's another skill probably isn't going to learn in Texas.
In a lot of countries, it's going to need to learn how to honk all the time, not just when somebody's actually in their way, but just to let them know, I'm coming, get out of the way. Don't even think about stepping in the street.
That's a simple rule. If you're approaching a stop sign, start honking.
That's right.
It's a good fact in the research side, right? But as far as technology goes today, we're probably not able to put a supercomputer on a rocket or in a car to actually be able to retrain a model, right? As the way that most of these models are being trained today. So I think there's a physical limitation in there of how we can build systems like this today. But like you said, it's really good to start thinking about that in the future.
Yeah, and in fact, that example was not mine. I got it from our chief scientist, who's a professor at University of Texas, and he actually worked on this particular problem for NASA with exactly that constraint, that there's very limited computing power available, and you can't, even if if NASA on the ground is able to detect that there's a problem, getting the signal to the rocket ship and having it make changes fast enough may not be good enough. So it needs a way to a lower computational overhead in making those types of dynamic model decisions. And so it's a really, really challenging problem when you really get into putting machine learning and AI onto devices, right, where they're not running in the supercomputers or in the cloud with infinite resources. Things get much more interesting.
Thanks, Matt. I'd like to move on to our next topic, which is AI in fiction or in making fiction.
Yeah, so I think my favorite recent example of AI in Fiction is the Ridley Scott series Raised by Wolves, which is on HBO. It's a really fascinating take on sort of a dystopian society of the future. Quick background on it is the human beings on Earth have effectively gone astray with various strange religious beliefs and other challenges. And along the way, robots and AI powered sort of androids even have come into power and have essentially run the humans off of Earth. And there's been this war. Long story short, it's a story of how a couple of these androids were essentially reprogrammed by a human to essentially raise the next generation of humans, but to do so better than the previous generation was raised, and how these two philosophies sort of collide, and how the AI itself, these androids that were supposed to be nurturing and programmed with the right morals to be able to raise this next generation of human beings, how they struggle to try to figure that out in the midst of very primitive situation. So it's really fascinating to think through the sort of that take on AI, but it brings up a lot of interesting questions and makes you think about some new things that I hadn't seen. It was sort of a unique take on the future of AI.
So I haven't seen this yet, but let me make sure I've got that right. So, and it's on my to-do list because I've heard other people talking about it. And I've tried to not find out too much about it so that I wouldn't get any spoilers, but it sounds like you're saying the premise is the robots have AI and they have been trained presumably by humans at some point to take care of humans better than humans were taking care of humans.
Yes. So what happened is at some point the humans and the robots went to war, and I won't go into too many details in the background of it, but there was essentially an experiment where one individual, I think probably one of the creators of the AI technology, decided to take one of these androids. This is sort of as the Earth is, or as the robots are taking over the planet and the last of the humans are fleeing and going to another planet. Reprograms one of them to be not a killer, a hunter and killer of human beings, but actually someone that's going to raise the next generation of humans. But it's going to do it the right way, so that the human race, the new version of the human race, doesn't have all the flaws of the current version of the human race. But he's doing this by programming an AI system to do it, as opposed to leaving it up to any other human to figure it out.
This has so many similarities to other science fiction that I know we've all seen and heard about. Everything from AI robots being programmed to protect us instead of destroy us, like in Terminator, to AI that is used as the governing body, and even most recently in Captain Marvel, I guess it was the Supreme Intelligence was the governing body of the Kree planet. And this sounds fascinating. Luke, John, have y'all seen this?
No, I haven't seen it, but I do like the premise because it follows that same story that we always talk about in AI. We're already talking ethics. I mean, we always want to make something better than what we have. We want to build a system that's faster or more efficient than we are. And why wouldn't we want to make even our offspring better than we are, right? So we know we can build a robot to do that because we clearly couldn't figure out how to do it ourselves. Good story premise. And and like I think like Jay said, in the similarities, I mean, of course, every time we build a robot race, we have to go to war with them. That's when humans can't war with themselves, we have to build other things to go to war with.
But I think that's the troubling part. I mean, if you think of fiction as blueprint for the future, why is everything involving AI completely dystopian? Why do all the humans have to die every time? If that's the case, if fiction is blueprint for the future, we better just stop.
Well, okay. Take the movie Her, for example. There the AI merely transcended him and left him. So it didn't destroy him, at least.
That's true. They found a better place to be. Yeah,
that's right.
You can break your species or break your heart. That's really the only two options.
Yeah, it was a bit of that, wasn't it?
Even in Ex Machina, we didn't actually see what happened. We know that the AI escaped and went off to live amongst humans, but
we assume
what happened after that.
Happy, right?
It may have been happier than ever after. We don't know.
In Ex Machina, I have to say, I enjoyed the movie and everything, But I found the least credible part, not even the AI pretending to be a human at times, but I thought, wow, that is some really good material science in that rubbery skin that passes for human without seams and everything and can be attached and reattached. I thought that's the real trick there. So
Yeah.
Really good robot tech. Okay. So that's our dystopian fiction for today. Let's move on to our last subject, which is just fun. What have you got for us today?
Well, I think in the things that are fun that I know you guys have talked about in previous episodes, where combining multiple forms of what I like to think of as human native interfaces, like images and text and video, and now we're starting to see these really fun combinations of these things. The ability to generate pictures from language, but the ability to actually critique art was one that caught my eye recently, where the AI is fed a portrait, some piece of art, and the task is to come up with a language descriptor that describes the artwork. So now it's got to be, it's got to use words and descriptors that describe the piece of art, not just some generic label like, oh, it's a picture of a man standing in a hallway. No, it's it's got to have some critique of the actual piece of work. And so that was an interesting one that I read, that was an interesting take on trying to do, not just basic image labeling, but narration of an image, but from the eye of an art critic. So trying to emulate an art critic. So I thought that was pretty fun. And it underlines a couple of interesting trends in AI that, where we're trying to combine the power of language models, which you guys were referring to before, with the power of some of the visual recognition capabilities that have been developed. And when you start putting these networks together and start training them on how to combine what they understand about both things like images and text, some of the cool things that can come out of that, which get much closer to things that as humans, I think we can identify with as being truly intelligent in some sense, although we can argue what that really means. But that was one that I saw recently that was a pretty interesting take on that.
So Matt, let me make sure I understand this, because as you said, we talk about these kinds of things all the time. We talked about it in our episode last week about the ability of AI to generate synthetic images that look really, really good because they've been trained on real images, or same with music. But we love reading the AI poetry, for example, or the AI screenplays, which are often hilariously bad because language has so many subtleties. So I got to ask, in this art critic one, this seems like it's combining two challenging models. One is how to rate art, and then one is how to express that kind of rating in human language in a compelling and not accidentally hilarious way. Is that what it's doing? It's got a model that's rating the art and a model that's then expressing the rating.
Yeah, that's what it's trying to do. And I think it's trying to not rate it so much. What would be interesting is to see if it could understand other qualities besides. It's more descriptive in nature, at least from what the examples I've seen. But it's descriptive in the sense that, these are like captions you might see in a art history book. So if you're looking at a portrait, it's saying, here is a woman of higher status looking sad, kind of looks like a bird that lives in a cage.
But they're not going to give you the art movement or the style per se.
No. But to me, that seems doable, right? You could have it detect the style of it. In fact, that might even be an easier task than this narration task, because it's almost like, I've seen lots of image labeling capabilities before, and they can get very nuanced, but this is a new spin on that, a new nuance that trying to align language, like you were saying, Jay, to the essence of what is sort of impersonating a certain persona, right? So here's what an art critic might say about this image, right? But I would say, I'm not an art critic, so I might say that looks like a guy with a large mustache. The example they show on the blog post was, his mustache looks like a bird soaring through the clouds.
Okay.
So
how can our listeners find this? What do they need to look up, or what do they need to Google to find?
Just look up, I think if you Google AI art critic, you'll probably find it on a blog or a news article that was published on this AI industry article that was published. So
can you submit your own art to it and have it
I didn't look that far to see. It looks like it was, there's a paper and there's some research that's done, but I don't know if they've released the model yet.
Yeah, I look forward to the day when these AI services more of them are out there for you submitting your own ideas to that you want them to do, or things you want them to describe, or things you want them to perform, like make a screenplay about 2 men and a woman who live together and, hijinks ensue or something, and just see where it goes with that.
Yeah, I heard about another one that's not as much fun, although it's maybe fun, or it could be disturbing, which is
those could be the same thing.
I don't know if this is, I don't know, you guys maybe have heard of this, but have you ever wondered if your face has been used to train facial recognition algorithms? So at some point in time, did somebody get a hold of a picture of your face and use it for training these algorithms? And so apparently there is I don't know if it's a website, or I don't know if it's even exists yet, but somebody has this idea of creating something where you can query and find out if your face was ever used to train a facial recognition algorithm. And basically what they've done is they've looked at some of the most common data sets that are used for facial recognition. Like, for example, the Flickr data set is one that's out there where they've taken a lot of and labeled pictures of faces from Flickr that are on the public feed, and they've used that to train facial recognition. And so apparently it's one of these eye-opening things where you're like, oh, well, I doubt my face was ever used. And then you can apparently find out if that was the case. And so I think that raises some interesting, could be fun, could be scary, not sure. Interesting one to debate, but I like those types of tools where they're very simple idea, and then it kind of relates to, it helps, I think, for us to understand some of the, what's behind what, some of these algorithms that are out there, and where that data comes from, right? And wait, I didn't give my permission for my face to be used. Why is it in this? Why is it in this data set?
On the other hand, you posted it in Facebook, tagged it 100 times. So also in Instagram and everything else, and you made your feeds public. So you kind of accidentally did give it permission.
Those of us that are naturally antisocial and have much more famous people that share our name probably don't have to worry about it.
That's right. Yeah.
I guess that's a good point, Luke Wilson.
I think the art critic is really interesting. And I think as these critiquing systems generate more suggestive critiques, I'm looking forward to the day that a generative pair or a reinforcement pair of models can be built that generates a piece of art and then critiques it and then uses that critique to generate a new piece of art. And we'll just see if a critic can actually produce art at that point. What would it really devolve into if you just kept feeding suggestions from an art critic back into a generative system?
You would just paint like
nothing but a blank canvas.
Yeah, that's right. By the time it's done, it would just be a white screen.
And this is a blizzard. Well, that's been a great discussion on the facts, fiction, and fun. Matt, I want to thank you for joining us today. Luke and Jay, as always, we'll be back again to continue this series on AI, facts, fiction, and fun in the future. Thanks for listening to the Austin Forum Upload. You can listen to additional episodes and check out a schedule of our monthly in-person events at austinforum.org. The Upload is a production of the Austin Forum on Technology and Society, a nonprofit organization here in Austin, Texas.